Okay, today we are going to be doing speed time graph, and this is a grade 8 and 9 topic. And then the first question we've got here today is that a runner runs a 160-meter race. The speed time graph above describes the motion. Work out the speed of the runner. Number B part says calculate the distance covered in the first 5 seconds. So for us to do the A part, we're going to go to the graph. The maximum speed is when the cyclist or the runner now reaches its top horizontal line. So the maximum speed is 8. So let's go and check how did we get this one from our graph. This is our graph, and this is the speed axis, and while this one is the time axis. So as the runner runs, so we have this vertical axis, okay, and the horizontal axis as well. So the maximum speed on the vertical axis is 8 here, as we can see it. So we will trace it. Does it match here? Definitely it matches here. At what time is it? You can even see it. It is at 5 seconds. So the runner reached the maximum speed at 5 seconds into his journey, and that means the maximum speed here also is 8 meter per seconds. 8 meter per seconds. 8 meter per seconds, and that's how we find it. Now let's go to the other part of the question, which talks about calculate the distance covered in the first 5 seconds. So let's go back to the graph and we'll look for the first 5 seconds, just like I did that time. So to get the distance covered in the first 5 seconds from the graph, we'll draw this line, we'll match it like this. I've done this before, and then we'll look for the area under this triangle. So we'll look for the area under this triangle. The reason is because this is 5 seconds here. So at 5 seconds, we can see that we have a triangular shape here. So to find the distance under speed time graph is equivalent to the area. So area is equal to the distance. If you find the slope of a speed time graph, obviously you are looking for the acceleration, but we are not yet there now. We'll still come back to that later. So what we can do now is that we'll say the area under the graph in the first 5 seconds is a triangle. So we've determined that one up there. You can see it as well. It's a triangle, and then the area is equal to the half base times height. The height is 8, as we have seen it here. So we use 8, and then the base is 0 to 5. 0 to 5, so we multiply by 5. Then the half. So if you put this in your calculator, you will get 20 meters. That's the total distance covered for the first 5 seconds. Thank you. So let's go to the next question. The next question will have is something very easy. Okay. The next question is something very easy. That's number 2. For question number 2, this one says a car moves 180 in total. 180 meters in total. The graph below shows its speed time graph. Okay, so this is the graph again. Work out the maximum speed of the car. So in this case, now we go to the graph. We go to the graph and we say, okay, let's find the maximum speed. The speed again is the vertical axis, while the horizontal is the time axis. The speed is the what? Vertical axis. So on the vertical axis, the maximum speed reached here is what? Is 12. We could trace it. Definitely, we could say that the maximum speed of the graph is 12 meters per second. That is done visually. It's very easy. So let's go to the B part of the question, which is calculate distance covered in the first 3 seconds. So just like we did in the first question, the first 3 seconds. Okay, from the graph now, I think we can see the 2.5 seconds is here, but that means 3 seconds is here, and then we could trace it, and if we trace it, we realize that it will actually also form a triangle. If we form a triangle, definitely the area under this triangle, which is 3 seconds, is equivalent to the distance covered in the first 3 seconds, and that means the area of a triangle is equal to 1/2 times what? The base times what? The height times the height. So we go again and we say, okay, area is equal to half. The base is now 3, because that is from 0 to 3 seconds, and then the height is 12 times 12, and our answer is 180 meter. So this is also very correct, and that's perfect. Now let's go to the next question for this. I believe this is self-explanatory. Okay, but I just need to do some input for clarity. Now this question says a train makes a journey between 2 stations, so probably station A to B. Then it accelerates uniformly from rest to a speed of 18 meters per second in 25 seconds. Then travels at a constant speed, so we have a constant speed, and finally decelerates uniformly to rest in 25 seconds. The total distance traveled by the train is 1,980 meters. Draw the speed time graph to represent the journey. So I think this is very easy as well. So to draw the speed time graph, we have to start from 0,0. So we draw vertical axis. We also draw our horizontal axis here. Okay, this is 0,0, in which the horizontal actually simply means, so we have drawn the time in seconds axis and the vertical axis, which is our speed in meter per seconds, and we are starting from 0,0, so we fulfill the first step here. The next thing is, as the question says, the train accelerates uniformly to 18 meters per second in 25 seconds. 25 seconds on the horizontal axis will be probably here, so we put 25 seconds here, and then 18 meters per second is on the vertical axis, so we put it here like 18 here. Definitely the two of them will meet at the point like this here, and then that means the train travels like this. Okay, so I'm going to draw it now for us to see. So we put our 18 here, 18 meters per second, and the first 25 seconds here. So the two of them, we'll draw them together to meet up here. And that means the train travels this way to meet here. So what this one means is that the train starts from 0,0 here and reaches this place at 18 meters per second here, and then 25 seconds. That means it takes 25 seconds to reach 18 meters per second in the first part of the journey, and we drew it like that. That is why this question says we should draw the what? The rise, and that is the acceleration phase. So you can say the acceleration phase is an acceleration phase. Don't need to write it, don't let me write it because of space. Now stays flat from 25 to 18. Let's check that from the question. After this, then travels at constant speed for 50 seconds. Constant speed, meaning that the speed is not changing. So at here, but on the vertical axis at 18 here, the speed is no longer changing, so it moves constantly like this for the next 50 seconds. Okay, for the next 50 seconds. So we count from 25 again, we add 50 seconds. That means maybe probably here, and that will be 75 seconds. 75 because 25 that it was before. For the next 50 seconds, that is plus 50. So we have 75. Perfect. All right. So that means, and it remains constant. So I'm going to draw a constant line now, and then it will remain like this. Perfect. Can we see that now? So that's the next one, which is flat. So we've gotten this part, which is flat. Then drops in a straight line to 100,0. Why do we get that one? So let's check our question again to verify that. It says, and finally decelerate uniformly at rest. To rest in 25 seconds. Definitely, it decelerates means it comes down. It decelerates means it comes down. It comes down to rest. To rest means 0. 0,0. Remember, we have 0,0 here. We have 0,0 here. So it is coming down to 0 here. But the time here is not 0. Okay, but the speed is 0. Decelerate, meaning that the speed reduced to 0. So 0 speed, that's what we are talking about. But the time it takes 25 seconds to do that. It takes 25 seconds to do that from our question. And that means additional 25 seconds to 75 here. That will give us what? That will give us 100. That is 75 plus 25. It gives us 100 seconds. So that means on the horizontal, I'll be having 100 seconds. That's so perfect. 100 seconds here. And then on the vertical, it is starting from here. So I can link the two together now. Perfect. So this is the diagram of the speed. So let me use this one to explain the solution. You see that they resemble each other. So the very first part is talking about the constant acceleration. So it was moving up, constantly accelerating. So that is the vertical rise. That is the rise. Yes, that is the rise. Then we have the flat, which is the constant speed. So it rises for 50 seconds and then decelerate, constant deceleration. It decelerates here consistently. Okay. So we have at this point is already at rest. It's already at rest. Okay. So it's already at rest and it's very, very easy. So that is how we get, and then you put your time in seconds and then the speed in meter per seconds. And if you draw it like that, you're going to get your full mark. You're going to get your full mark. Now let's check the second question, the second part of the question. It says, work out the total time for the journey. Okay, but we know the total distance of the journey. That's perfect. So let me go to the next page now to solve that. Question 3, continue. So how do we address this question? What happened here is very easy. So one thing we know is that for the part B, we calculate the total distance using the area under the graph. Okay, there are 3 areas under the graph. Maybe I should quickly sketch that graph here, what we got above. So we have this part, and this part as well. This is the time and this is the speed as is. So the first part is the left triangle. Okay, so we have this part. So this is the left triangle 1, and then we have the right triangle 2. Good. So, and like I said, the area under this graph gives us the total distance, right? The area under this graph gives us the total distance, the area under each of them. Now, what we can do is that the shape is a trapezium. Of course, we have seen the trapezium with 18 as the height and 100 here. Then we have 25 here. We have 75. So if you can pick that one now, that's very good. So area for the first acceleration, the area is going to base times height times half, and that is going to be 1/2 times 25 times 18. So the area gives us 225 meter. That's area under the graph is equal to the distance covered. So in the first 25 seconds, the train actually covers 225 meters. In the middle rectangle, is it rectangle? Truly it is rectangle. We can see it here now. This rectangle is a rectangle. The middle rectangle is 50 length by length, and the height is 18. The area under this graph is length times what? Length times breadth. Length times breadth, or the height of the graph, which is 50 times 18, that is 900 meter. And then the height of the triangle, which is the deceleration, so to area under the graph for the third rectangle, and that gives us 225 as well, just like the first one. So the total distance traveled now, we could say that the total distance traveled is equal to 1350 meters, but the train actually travels 1980 meters. But according to the graph, what we got from the graph now, the total distance traveled is 1350 meters, but the train actually travels 1980. From our question which was said, so we adjust the constant speed duration. Let the total time be t. Okay, let the total time be t. So what we need to do now is to adjust the total time duration for the constant speed, because we know that deceleration is constant and the acceleration is constant. The deceleration and the acceleration part is constant. Yes, this part is constant, it takes 25. Then this one also, deceleration takes 25, and it's coming down. Now the next thing we could do now is that the acceleration is 25 seconds. Constant speed time, we don't know it yet. That means we will assume we don't know it. That is x seconds. And then the deceleration time is 25 seconds. The total time now is supposed to be 25 plus x plus 25, which is equal to x plus 50. X plus 50. Now, new total distance equation. We can now calculate that 225 is the total distance for the first part of the journey, where that one is known. But for the rectangle, it will now be 18, which is the height, but the speed doesn't change. Okay, now the height times the x, that is the time, which is the horizontal. It's no longer going to be 50 as before. It's now going to be extended. Then the second triangle, which is for the deceleration, is now 225. So we've calculated that one already. And then, but the total distance, according to the question, says the train travels 1980. So we are going to add everything together, and that will give me 450 plus 18x equal to 1980, just like the name of a year. So we could see that 18x is equal to 1530, and x is going to be equal to what? 85. So that x is 85. Final answer, x is 85. Okay, and the total time covered now will now be 25 for the first journey. The constant aspect is 85 plus 25. So the total time taken for the journey is 135 seconds. 135 seconds. That will be our answer, and that's very, very easy. Okay, so this is even self-explanatory. I'm just trying to put some new extra explanation to it input in case you don't understand it directly. So it's easy. Okay, thank you. Now I've got some questions for you. You can try this one. You can try this question out yourself. It's very easy. Try to attend. Right, you can also reach me on this one if you need one-on-one tutorial. You can reach out to me on WhatsApp. It's +234. So let me write the question. Something +234 81032777436. This will make you to land on my WhatsApp page, and you can also follow my WhatsApp channel where I show all my video as well, including the one I'm not showing on WhatsApp on the YouTube. All videos are there, and a lot of matrix are on that YouTube channel as well. The WhatsApp channel as well. You can also reach me on this if you want to book one-on-one session with me, or if you want to book one-on-one session with me, you can also use my WhatsApp number for one-on-one lesson. Thank you, and I will see you in the next class. Bye bye.